Hi everyone, let's solve today's daily challenge, that is binary tree zigzag level order traversal. So in this question we are given the root of a binary tree and we have to return the zigzag level order traversal of its node values, that is from left to right, then right to left for the next level and alternate between, right? So we are just given a binary tree and we have to traverse it level wise, and we have to have a zigzag level order traversal, right? So what is zigzag level order traversal? That is written here, from left to right, then from right to left for the next level and alternate between. So that is, if we like in this particular tree, if you see, there are three levels, right? We have three levels here. So what we have to do, we have to first take we have to start from left to right, right? So here we only have one node, that is 3. Then we have to go from right to left for the next level, that is from here, right? In normal BFS, we would have gotten 9 and 20 in the level, but we should have 20 and 9 in the output. So that is, we are taking it in reverse order. Then for the next level, we have to take it from left to right, that is 15 and 7. So that is the result given here, right? So it's normal BFS. Let's take another case and let's understand the question clearly, right? So let's say we have this kind of tree. Okay, let's give them name 1, 2, 3, 4, 5, 6, 7, 8, and 9. So let's see what will be the zigzag pattern here. So first of all, what will we get? We will get 1, and after that we have to get the next level in reverse order, that is 3 and 2. Then we have to get the next level in from left to right, that is 4, 5, 6, and 7. And then after this level we will take the next level in this way, right? So I hope now you have understood what the zigzag pattern is, right? So how do we do BFS? We take a queue, right? We take a queue data structure, and using a queue data structure we do BFS. So how do we do BFS? First we have our queue, right? So whatever, first we take the root inside of the queue. So right now we have 1. Then what we do, we traverse for all the elements present inside of the queue right now. Then we take the next the left child and the right child of the nodes that are present inside the queue. Right now it is only 1, so what do? We take 2 and 3 inside of the queue in the next iteration. Then we pop 1 out, right? Then what we do, we check what are the elements we have inside of the queue, right? So we have 2 and we have 3. So what will we do? First we will be traversing for 2, right? So we will take the children of 2 inside here. We will take 4 and 5, right? And we will pop out 2. So we will get 1, and after this we will get 2, right? And after this, in the next iteration, we will be having 3, right? So we will push 3, the children of 3 here, right? So we will get 6 and we will get 7, right? And we will pop 3 out. Now we have gotten this, right? We have got 1, we have got 2 and 3, right? This is the next level. Now what do we have to do? We have to again do the same. Whatever elements are present inside of the queue, we have to traverse for them, and we have to just push the children of these elements and pop them out one by one, right? So this is the BFS, normal BFS traversal. Now in this BFS traversal, what we have to do is we have to take like all the even levels, we can say, in reverse order, right? So we should not be having 2 or 3 here, we should be having 3 and 2 here, right? Similarly, if we traverse for this, we will be having this in the similar way. This is an odd level, we will not do anything for this level. Then for the next level, we will be having 8 and 9. So what do we need? We need 9 and 8. So I hope that is clear. So for reversing a particular level, what we'll be doing, we'll be having a flag variable, and we will check, we will just alternate that flag between 0 and 1, right? So to just know that whatever the level we are currently at, right? So let's see by coding it, then it will be more clear to you. So first of all we have to check, right, if root is null, right? If it is null, then we don't have to make any queue or anything, we can simply return, we will be getting nothing, right? Now if root is not empty, right, if root exists, then what we have to do, we have to create a queue, right? We'll be creating a queue inside of this, right? We have created this queue, and also let's create this vector here, let's call it answer, right? And also create a flag variable using which we will alternate between the levels, right? So initially our flag is 0. Now what we will do, first we have to push the root inside of the inside of this queue. So we'll be having, oh sorry, it will be root, right? Now we will be traversing inside of this queue. So we'll just do what we just discussed, right? That is the normal BFS traversal. We'll say if queue is not empty, then consider all its element. So all the element, let's take n for that. So we'll be taking all the elements that are initially present inside the queue, the number of elements, and then we will be traversing for them. So we'll say int I is equal to 0, I less than n, and I plus plus. Now what will we do? We will take the front of this queue, right? So let's take it inside of current variable, right? Let's have the front of the queue, and also let's create a vector for this particular level, right? Because we'll be putting all the values inside of this particular level inside of this vector, and we will be, if we need to, it will depend upon our flag variable, right? If it is 1, then what we will do, we have to reverse this particular level. So our level will be inside of this vector, and whenever flag will be 1, what will we do, we will reverse our vector and then push back it inside of this answer vector, right? So we will also pop this out. Okay, now what will we do, we have to first push back whatever value you have at this current position, right, inside of this level. So we'll say level dot push back this value, current value, right? And then we will simply push the children of this particular node inside of our queue. That is, we will first check if a left child exists, right? If it exists, then we will say what, we will just simply push it inside of the queue. We will say queue dot push this particular element, that is current of left. Okay, similarly we will do for the right one, right child, that is right. If it is not equal to null pointer, then we will push it inside of the queue, current right. Now we will write the main logic after we are done, after this for loop, right? We will be creating a level after this for loop. So what we have to do, we have to check if flag, right? If flag is 1, then what we have to do, we have to reverse the vector, right? So what we will do, we will say reverse level dot begin comma level dot end, right? And after this we will push this vector inside of our answer, right? Otherwise what we will do, also update the flag for the next iteration, that is make flag 0, right? And after this, if the flag is 0, then what we have to do, we have to simply push this particular level inside of our vector, right, without reversing it, and also set flag to 1. So this flag will be alternating for the levels, right? So after this, after we are done with this, we have to simply return our answer vector. So let's quickly run it. Okay, answer, okay, it's answer dot pushback, right? It's a vector. Okay. Okay, so it's accepted. So that is how you have to solve this question.